Hi there, welcome to a quick tutorial. I'm going to be answering question number 1 here from the worksheet titled Enthalpy Calorimetry. So this is worksheet 16.4. At the top, it's the second of the 3 that are on our D2L page. So the question asks us what happens when potassium chloride is dissolved in water in a calorimeter. Now this is a pretty standard practice where, and I'll draw a diagram first, we'll take our styrofoam calorimeter, which has 2 lids over top, and it's filled with water. Now the water is at a set temperature. So here, the initial temperature of the water that we're told in the question, we're being told that it drops from 31 to 21.6. So its initial temperature is 30.0 degrees Celsius, as per the question. Then we're being told that a sample of KCl is being added. Now, what you're going to start to realize is that dissolving processes are endo and exothermic, and depending on the substance, it can absorb energy or release energy. So once the potassium chloride is added, it's noted that the temperature change of the water occurs, and its final temperature is 21.6. So looking at that there, before we even start, if we take the change in temperature, which is final minus initial, and we do that there, we'll find out that the temperature change is negative 9.4 degrees Celsius. I'll just double check that with the calculator. So we'll do 21.6 minus 31, and we've got negative 9.4. So what does this tell us? This is the temperature change of the water, which means water lost energy. Okay, and if water loses energy, that means the substance must gain energy. So the enthalpy of solution, because it's dissolving, for potassium chloride is going to be a positive value, okay, because it's absorbed that energy. So now all that's left to do is do the math for that. So if the water loses energy, the potassium chloride must be gaining it. So we can start off like this. The heat of the water, which describes its thermal energy gain or loss, is equal to mc delta T. Okay, we're told in the question there are 75 grams of water. Specific heat capacity is 4.184 joules per gram degrees Celsius, and then we found the temperature change as negative 9.4 degrees Celsius. So look at the negative signs there as we punch that in, and it's going to tell us that the water, as we get a number here, has lost 2,949.72 joules. Pay attention to the units there. So for calorimetry, the water is essentially the surroundings because it's not undergoing the change. The potassium chloride is going from solid to aqueous, right? The process that it undergoes looks like this. And now we know that we can add energy to it because it's an endothermic process. So if this is the system and we know the surroundings, what we learned is that the energy of the system is equal to the negative value of the energy of the surroundings, right? Now, because we're working with a chemical reaction, instead of using Q, we just put delta H, and that's really the difference between it. So we know that delta H is equal to negative Q, which means it has to be equal to negative 249.72 joules, which gives us a positive value for that there. Okay, and we'll round at the end there. Right, and that's our enthalpy value. We're not being asked for the molar enthalpy, right? But if we were, then we can just divide that out by the mass of potassium chloride that's involved in there. Okay, so really to state our final answer here, potassium chloride as a solid plus 2,949.72 joules produces potassium ions and chloride ions. So this is the dissolving process, or you can say this here. Right, we talked about a bunch of different ways to write this. AQ and then delta H equals 2,949.72 joules. Okay. So for this here, if we wanted to take this one step further and find the molar enthalpy, Okay. What we can do from here, remember that molar enthalpy has the value to it, so of the solution is equal to delta H divided by N. We know delta H as 249.72. We can find the moles. Okay, moles equals mass divided by molar mass. And we were told in the question here there are 12.8 grams. And the molar mass of potassium chloride, we just add up the values on the periodic table. We're going to get 74.55 grams per mole. Okay, and this is going to give us the energy change for this specific scenario. And it's going to be 17 point, and I'm going to convert, actually, let's leave this out for now, 180 joules per mole. Or if we convert that into kilojoules, say 17.2 kilojoules per mole. And that's the molar enthalpy of the solution. So that means for every mole of potassium chloride that dissolves, it's going to absorb, because it's positive, and you can put that if you think you'll forget, 17.2 kilojoules. All right, so hopefully that little tutorial helps there. You can do it in one step as we had talked about before. Okay, combining everything together. All right, just knowing that the fact, right, if we want to look at that in one step, in the end, if we're asked for this molar enthalpy, we can say delta H divided by N. We had said delta H is equal to negative Q over mass divided by molar mass. Just make sure you understand what values go with which. Okay, then we can go one step further. Negative MC delta T divided by M divided by molar mass. So that's of the surroundings. That's of the system because we put the negative sign on the top. All right, and this would be the process kind of in one step, but we broke that down by understanding. Hopefully that helps clear it up. All right, and good luck with the rest of the practice.